Okay, what is the next step?
The next question is, if you completed the individual preparation assignment before attending the group meeting.
Yes, Ali.
3.
Who's playing the guitar?
These guys next door, you can hear that? It's just the office next to me.
Yes.
That's
Sounds
our
good.
division manager. Yeah, they play a lot. I'm not that good at guitar. Oh, and he has this this thing where you can take any card like this and just punch it and make a guitar pick out of it. It's really cool. Where did I do it?
Okay, so number 3, the symbol for the true population proportion is what is the following?
The last one?
Yep. P.
The symbol for the true population. Oh, yes.
For the true
Okey-doke.
population proportion is P.
Yes. For the next two questions, suppose n is equals to 100 and p is equals to 0.25 and p hat is equals to 0.10. The requirements for constructing a confidence interval are satisfied. We have the formula.
You have to use
N multiplied by p. A ver.
and the first condition is equal 25 and the okay.
So N is
Oh, yes.
100 times P
And minus 1 divided by what? 100. What?
minus
Wrong. 1. Right. 90. I think so. I think the requirements are satisfied. 10
Yes, and 90.
and more 90.
100 times 0.75.
Oh. Hypothesis.
Okay, it's okay. We have true.
What are the requirements to
The requirement
conduct a hypothesis test?
For the hypothesis test, you have to have a simple random sample and the confidence interval is
normal distributed.
it's normal distributed because this
is 100, the sample size.
Requirement met.
Oh, I'm talking about, oh, wait. For a hypothesis test, conducting a hypothesis test. Before hypothesis test.
Okay, for a hypothesis test.
So for the hypothesis test, isn't it the P?
Well, shoot.
Well, can't we figure out what the
So the p-value, the z-score, and the standard deviation, would you say that's, we have the sample, the p-score, and the p-hat. So I guess for this one, for a confidence interval, we have p, we have n, and we can use p and n to determine the standard deviation of p hat.
yeah.
So it looks to me like we have everything we need.
I agree.
Yes, it looks like we have the report.
Okay. The requirements for conducting, without the C, a hypothesis test are satisfied. So for a hypothesis test, we need sample size. P is the population.
Sample size.
P is the proportion.
And the estimates of the proportion. Yeesh. The good part is we can take this again if we get it wrong and just switch them. Just kidding.
Yeah,
We're recording.
sample, we already have a good sample size.
But I think it's true. We have several numbers there.
100 in sample size. A lot.
And I think we can figure everything else out with those 3 numbers that we have.
Right.
Yes. So, do we go to question 6?
Yeah. A study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these 45, the defendants were found guilty. Oh, of these, 45 of the defendants were found guilty. Find p-hat, the point estimate of the proportion of the first-degree murder defendants who are found guilty in this state. Round to 3 decimals.
Okay, so N is 60. Okay.
And what is X would be 45?
Yep. Now, right, it's 45.
Yeah, 45.
So
And
then, if you look at what we're looking for here,
it will be 75.
p hat equals X
divided by
over N.
50
Okay,
is the proportion
so p hat
is
equals 45 over 60, which would be, it's going to be 7.75.
Yeah.
0.75.
But
Yeah.
we're just getting a percentage, so
0.750.
750. Right.
0.75. You're right.
Okay. And then 95% confidence interval.
What are you doing?
With 2
Yeah, we
minutes.
have to
I'm not doing what Jared does.
calculate the margin of error.
For which one?
7.
What?
He's already working on 7. He jumped ahead. Create an
What?
Yeah. It's 0.750, right?
Yes.
Okay, good. Okay.
Number
Okay.
6.
Number 6. Yes.
So that would mean that alpha equals 0.05 and 95% confidence interval.
Okay.
True proportion of first-degree murder trials in the state with a gun. Okay, you can put your answers.
So it's going to be
Margin.
the 1.96 to the square root of times the square root of p hat, which
Is it
is going
p
to be
hat?
that, yeah, 0.75 times 1 minus 0.75 over 60. Correct?
Where is that formula?
Formula.
Where
P
is that
plus or
formula?
minus, well, the margin of error is Z, is that Z number, which is in that
Yeah.
box. And we're doing a 95, which is 1.96
Right.
It's confidence.
times the square root of P hat times
P hat is
1
7.
minus P hat over N.
So we do what's in the parentheses first, right? So 1 minus p hat, and then
Yeah.
divide that by 60.
Yep. So our P
Okay.
hat is 0.75 times 1 minus 0.75 over 60.
Point
I always forget to do the square root and then I'm screwed.
I know.
25 times 5.
So that is
How
0.004.
do we
And
get
then
the-
do we multiply
Right.
1.96 times the square? We do the square root first.
Are you using the Excel spreadsheet?
No, just
No.
calculate. Just using the head to calculate the mind.
Okay.
Like
So I'm not using my mind. I'm using a calculator.
Okay, no problem. We can use that too.
How do we get margin of error? Just please remind me the formula because I don't find it.
You don't?
Margin of error is Z.
Uh-huh.
That Z number, which if we're doing a 95% margin of error, is going to be that 1.96
Mhm.
times the square root of P hat, which is 0.75, times 1 minus P hat, which, yeah, is 0.75, over N. I got 0.109567.
It's 1
For the
1
margin
0.
of for the margin of error.
Yep.
It's 1 1 0.
That is
Yep.
not what I got.
Round it, that's what it would be.
Okay.
Round to the
Okay,
nearest.
so show me the math again on this because I set it up right, but I just think I might have done the wrong order of operations or something.
We have Yeah, we can just leave the z and start calculating what is inside the root.
Okay, let me ask you this. So we have 1 minus 0.75 divided by 60, right?
Yeah, you can do that, but also you can do 0.75 times 0.25, which is divided by 60.
So 1 minus 0.75 is 0.25. That divided by 60, I got 0.004.
And times 75, because you have
1 minus 0.75, that's p hat. So I got
Yeah.
0.25 divided by 60.
But the formula,
Right?
you should
the formula says that we need to use the z-score, but not the p hat, but the p, the true proportion, I think. So it's it's 60, right? No, 45.
yeah, it's 60 for n.
It's 60. It's 60.
You should do times 75.
Would do what times 75?
It's like you have p hat times 1 minus 0.75. This is the formula inside the square root. It's p hat.
Oh, that's just for the stand, but that's the standard deviation.
Can you see what I'm
of
doing
p
right
hat.
here?
Well, square root of p hat times 1 minus p hat divided by n, and it's when it's the square root. Okay.
Yeah, because
so the standard deviation of p hat is that far right where it was the square root of p times 1 minus p over n. So
Yep.
So when do we do the entire square root?
Once you figure out everything inside the square root.
Okay, I think that was the problem I had then. Okay, so then if we do, I see what you were saying there, Herman. So,
yeah.
So I did like 1 minus 0.75 equals 0.25 times 0.75 equals.
you guys got, what'd you get, point what?
1 minus 0.75 equals 0.25 times 0.75 equals 1875 or 0.1875 divided by 60 equals 0.003125. Square root of that is 0.0559016. And then times that by 1.96 and you get 0.10956. If you round that up, it would be
That's what I got.
110.
That's what I got. Okay.
0.110. You get what I'm doing?
Yeah, that's what I got. I got the same thing. So I'm just gonna do it one more time. Okay, hold on. 0.75 times 0.25 divided by 60. And that is all square root times 0.1095. Okay, yep, 0.1096. 0.1096, yeah. 0.109. So that is our, but is that's our margin of error because we multiply it by 1.96, right? With the z-score.
So can you show me the formula that you are using? I think I'm confused in the formula. I had a different one. Can you show me the formula?
Well,
do you see this right here?
Yeah, but that's kind of, that doesn't, he wants to visualize it probably the way we.
Okay, let me see if I can find it in the book.
And number 3, right, in the book, M equals to z-score. P 1 minus P multiplied by P divided by N.
Here's this Z. Are you seeing right here? Z star, the square root of P hat times 1 minus P hat over N. This part from here to here is the margin of error.
That is chapter 17.
Chapter
Yes.
17. Yeah, and I think it's in 16 too. Maybe I can find it easier in 16.
Oh boy, I forgot my charger today. I left it at home from last night, and I'm in about another 20 minutes or so. That's about all I got.
We can do it.
Oh boy, I don't know, man. That's 18 questions. Okay. So then for that lower, so we take 0.750, and then we just subtract the margin of error and add the margin of error, right? For that lower bound, upper
For the
bound.
confidence interval, yes. We have to add or subtract P from that margin of error.
Okay.
So yeah, it's just, see on this is the whole up, this is the lower bound, this is the upper bound. If you do everything past the minus, that's margin of error. Everything past the plus, it's the same thing, margin of error.
Totally. Yep. Remember that.
Plus or minus the margin of error is your confidence intervals.
Uh-huh.
Okay, who
So
is
the
going?
confidence intervals are 0.64 and 0.86, right? 86.0.
Well,
Those are the
859 is what I got.
Interval.
0.641 and 0.859.
You got what?
I got, okay, so I did 0.750 minus 0.109, and that is 0.641. Oh, you did 0.110.
Yeah, because if you round, that's
My bad.
it's rounded 3
Yep.
decimals.
So it's 0.640 then, and
Yes.
0.860 then.
Yes, I got 0.640 and 0.860.
Okay. If you increase the sample size from 860 to 80, what do you expect to happen to the width of the confidence interval? It will decrease, right? Right?
If you increase the sample size from...
Oh wait, I wrote that down. Hold on. What happens to the confidence interval as the level of confidence increases? If it goes from 95 to 99, the confidence level increases.
Oh, it increases.
Yes, as the sample size changes, if the sample size increases, the confidence interval will decrease.
The confidence interval will increase?
If you increase the sample size,
This sample size. I'm talking about sample size only.
Uh-huh.
if you
Yeah.
increase the sample size, the confidence interval will decrease or increase?
Increase
If you increase
confidence
the level of confidence, the confidence
Oh.
interval will increase.
Gotcha. That makes
It
sense.
because you
Okay.
are
Where was that?
If you increase the sample size, says... Are you in
You
question
are
10, right?
confident.
Increase the sample size. If you increase the sample size, then it's going to decrease the confidence interval.
Uh-huh, yeah.
What?
Decrease. Hold on. Whoa. What was all the increase talk you just had then?
That was for what happens if you increase the confidence interval.
Oh, right.
So if you go from a 95 confidence interval to a 99, it's going to increase the size or the width.
Which question are you, Tiffany?
10.
Oh, I was just doing something off the homework.
Oh.
So this answer is decreased because we're talking about sample size. So if the sample size
Okay.
increases, then it's going to decrease your confidence interval, the width of your confidence interval.
Yes. That makes sense.
Decrease or increase or stay the same?
Decrease.
Decrease.
Okay. We can't help you with the homework.
Yeah, that's against the rules.
Yeah.
No, it actually said on the homework that we were supposed to go over that in our group, but we don't have time.
Okay, so are we on number 11?
Oops.
8, 9, and 10, right?
Was there a negative number in those upper or lower bounds?
No.
Because it's 0.75 and then the
Okay,
confidence
gotcha.
and then the margin of error is 0.1, so there's no way.
Minus 0.10 equals 60. What? Plus this. Okay.
To conduct a hypothesis test for one proportion. P equals 1/2. What's the smallest that n can be? Remember this one. We put 40 last time, and it was 1/4. So if it's 1/2, my guess is it's 20.
$20.
Does that make sense? Does anyone not agree with me?
Hypothesis.
Prove it.
You're going to have to prove it to Herman. Okay, so if we know,
It's not 13.33.
Oh, I proved that I was wrong.
he proved that he was wrong.
What we did last time was it was whatever a fourth of n whatever.
I know how to do this already.
Right.
You have to do both sides.
Yes.
Use the bigger number. If the bigger number satisfies both sides, if not,
For one proportion, 2 requirements must be met. Okay, so are we all agreeing that's 20?
Yeah.
Yep.
Agree.
The next one?
To conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose that P equals 1/10. What is the smallest n can be for both requirements to be met?
100.
Yep. Do you guys know how we're getting that number? I know Greg knows.
No.
Okay, so that first equation, the
It
n
needs to be 10.
n
And
times
so
p hat.
x times what? Equals
What?
equal. Trying to figure out how to word it properly.
Okay, so you know how to figure out the requirements. You do the NP is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10, correct?
Yes, correct.
So we're punching p into that formula. So if you have n times 1/10 is greater than or equal to 10, you have to divide both sides by 10 to make it just n on one side, and then the answer is going to be on the other. That's how we're figuring.
20 satisfies both sides.
For number 11?
For, yeah, number 11.
So for 12, it's going to be 100. Does that make sense, Edgar?
I'm trying to complete the equation. So
if you have
10 multiplied by 1 minus p equals 10. So to find n,
if you find
what is p? And then in question 12,
it's 1/10.
1/10.
So
okay.
n times 1/10. So if you just write it 1/10 is greater than or equal to 10. To get rid of that 1/10, you have to times both sides of that equation by 10. And then you're going to get n is greater than or equal to 100. Because 10 times 10 is 100.
Yeah. For me, it satisfies both sides. One side is 90.
I got it.
Another side is 10.
I got it. Thank you.
Five more questions. 6 more questions.
Okay, guys, I have to go now.
Okay.
Okay.
Save your test. We'll give you some info on the last 6. Okay.
Okay. Thank you. I will compare them. Thank you. Have a good night.
You
Okay, we'll
too.
see ya.
Okay.
Bye.
%60 of the macroinvertebrate water quality indicators have historically been associated with good health. So X then, okay, P equals 38. I'm working on this one. Are you guys working on this one already too?
Yeah.
Okay, 38 divided by 80 is 0.475. Listen, if the conditions for conducting a hypothesis test are not satisfied, then we can't do the next 5 questions. That's my deductive reasoning. P hat, what'd you guys get?
Pihatcito is
38 over 80.
P hatcito.
0.475.
That's what I got. Hasta ahora se te cayó.
Yes.
Test the stick.
0.475.
Is that not 1.96?
What? 475.
No, the test statistic.
Z.
Oh, that's a
1.960, right?
Wait.
Am I right?
Question 38. The Z-score.
Oh, so it's p hat minus p.
The test
Wait.
statistic.
Don't we already have Z?
Where?
Well, if the confidence interval is 0.05, doesn't that mean that it's 1.96? Am I not on the right track here?
Well, you are, but it's probably not.
Okay. So it's x
I think
bar
you want-
minus mu over the standard deviation. That's Z. But we don't have mu. We don't have standard deviation.
The test statistic. Are you in question
14.
15?
14.
14?
14. Oh, 15. Sorry, 15. The test statistic.
Statistic.
Over 0.60 times 1 minus 0.60 over what's n? N is 80. Square rooted.
Where did you get all this information?
Compute the test statistic. Z equals p hat minus p over the square root of p minus 1 times 1 minus p over n.
Okay. I don't.
Formula.
The only one that I wrote down was x bar minus mu over standard deviation. So with
It was at the end of chapter 17.
At the end of chapter 17, the estimator you will use
Oops. 0.4 times 0.6 equals 24 divided by 80 equals squared is 0.05.
under summary.
I don't find anything in the summary.
It actually was in the video, but let me see if I can
Okay.
find it.
Score requirements.
Oh, here it is, Z. Z equals value minus mean over standard deviation.
Z equals, yes. So x minus the mu over standard deviation. How do you get, what's the mean?
P.
Huh? P?
Yeah, which is your proportion, which in
Which is
that
60.
question
0.6.
would be what?
0.6.
Right.
So then x is,
Your value is going to be your P hat.
okay.
So X over N. So that
So
0.75.
Z equals P
Oh, 4.75.
minus P over standard deviation. Okay, I see what you're doing here. Okay, so then we have to do 0.475 minus 0.6 divided by standard deviation. And the standard deviation is, we gotta get that. Standard
P
deviation
times 1 minus P
P
over N.
equals, right,
Rooted.
equals with p hat. What was p 0.6? 0.6.
P was 0.475.
Shoot, what was n? Oh, 80. Okay. Okay.
Negative 2.282.
0.003. Is it, you guys got 0.003? No.
No.
Is that
The
square
standard
rooted?
deviation? Oh, square
Square
root.
rooted.
Ah, 0.0547.
I know that gets me every time too.
0.056.
0.547722. Yes.
So we did 0.056. So then the standard deviation is 0.056.
5.5.
That's what, sorry, 5.5. So then we got z equals 0.475 minus 6 divided by 0.055. And oh, that's not right. Okay. 0.475 minus 0.6 equals negative, right? Divided by 0.055. So I get negative 2.27. Yikes.
I got negative 2.282.
I get
And that's what I
negative
got.
2.272.
That's what I
Okay.
got using the Excel spreadsheet also.
Let me do
I
that one more
didn't
time.
round until the very end. Oh, and that's what you got with the spreadsheet?
Yes.
What'd you get? Negative 2.28?
Yes, negative 2.282.
Okay, so why did I get 272? So let me do
Because
this
you
again.
rounded. You're not supposed to round till the end.
So I rounded what? The z-score?
You rounded the standard deviation.
That's what I meant. 0.547. Is that what it was? 0.0. Crap. Okay.
And the p-value, I got 0.022.
2.3, I got 2.25.
0.0547. Okay. So then
0.2.3.
0.475 minus 0.6 divided by 0.0547 equals negative 2.285. So you got? Or negative 2.282?
Yep.
82?
Ah,
I got negative 2.285. Then we got to add a couple more numbers in there. Okay. So the p-value is 0.6.
0.6?
Right? Yeah.
No.
No,
Oh, no.
because p-value is the area basically. If you look at your normal, punch in your z-score, 2.2, your area of your normal probability.
So negative 2.
Oh wait, you might be right. What are we looking at this one?
This one we're looking at.
Is it greater than? It's less than.
Okay, so then it is 0.0112, 0.011.
0.0112. Yep, 0.011.
Okay.
You're right.
What is the decision for this test? It is less than, so we
reject.
This gets me every time.
Reject the null.
Reject the null. Okay.
If the value is low, reject the null. So if it's lower than that, if it's lower than your,
then the confident within the whatever.
Yep.
Okay.
Then you're rejecting.
The significance level. Okay. Which of the following best summarizes the conclusion of this test?
It's got to be sufficient evidence. There is sufficient evidence to conclude the water quality in the area was not decreased. There is sufficient evidence to conclude the water in the area has decreased.
That one.
Decreased.
has.
And why did you get 0.011 in the p-value?
Oh, when I put it in the probability applet, it's less than.
Oh, well, in the spreadsheet says that the p-value is 0.022.
Because it is. If it's a two-sided test. But it's
Yeah,
not.
but if
It's
it's
less
less than, which this assign on this one, the question it says right here, the alternative is less than. They're looking for less than 6%.
Oh, okay.
So it's only one-tailed, which means we're only using this one.
Okay.
Left.
Okay, ready to submit?
Oh,
I'm running low on battery here.
finish everything?
Okay, one. Guess who got 100% on their test?
Did you really?
You guys did. With me. Okay. Awesome.
Wait.
Good job. Okay, my battery is running slow and slow. Would one of you be willing to help? What's his name with the last couple questions?
Sure, I can do that.
Edgar's not too
All
excited
right,
to
Pete.
volunteer.
Oh, no, I said I would.
I said I was just making fun of Edgar. He's over there like, oh, I
okay.
don't understand. No se habla.
No entendí. I didn't understand the last part.
No Nintendo.
Internet.
My internet is and hey, I just I mean, it's frozen. That's a good one. All right, guys. Okay, so the first step with this stuff is who's getting what for who?
Who's giving what for who?
You're putting it together.
I'm putting it together. I will send it out to everybody for your approval. If you think it looks okay, then I will, as soon as I get everybody's approval, then I'll submit it to the teacher and we'll see if he approves it. And then if he does, we'll go from there, okay?
Okay.
Sounds good. Thanks, guys.
Thank you.
All righty, we'll
Bye,
see ya.
guys.
Bye.